Okay, so this is the introduction of the ANCOVA assignment that we're going to do. So the first thing I kind of wanted to talk about is, or some things that I'm going to talk about is, what is an ANCOVA, the assumptions, when should you use it, why do you use it, and then also, I think I just said assumptions, but assumptions too, since I can't remember if I said that. And then also I'm going to talk about what I'm going to be doing with my research data, or essentially the problem that I propose for this assignment. So to kind of get started, the first things first, we have to ask ourselves, what is an ANCOVA? So with an ANCOVA, it's essentially it's essentially an ANOVA with a C. So it's a statistical procedure that tests for the overall model of fit, while controlling for a covariate. And a covariate is a continuous variable that possibly has an influence on your outcome variable, dependent variable, whichever one you would like to say. You would do this. You would want to control for or include a covariate in order to reduce within group error variability. So kind of to have your covariate account for some of the unexplained variants, and that kind of leaves more variants that can be explained to the predictive variable that you're proposing. And you also want to include covariates to eliminate confounds, so kind of like to eliminate noise. Basically, it's to make yourself or make your predictive variable more so looked at. That's the only way that I can kind of describe it. Yeah. So moving along. So you're gonna use an ANCOVA when you have a predictive variable, a categorical predictive variable with more than 3 levels. So you have group 1, group 2, group 3, and more if that's what you're doing. Your covariate is going to be a continuous variable, and your outcome variable is going to be a continuous variable as well, interval-wise. Yes. So the assumptions of an ANCOVA are essentially the same as an ANOVA, but with 2 additional assumptions. So the first assumption is homogeneity of variance. This is the variance between groups. Variance is the variance between groups. Whatever. No, not whatever. So homogeneity of variance is where you want your variance between groups to essentially be the same. Independence between observations refers to having your observations not influence one another. So one score will not be dependent upon another in short terms. Normally distributed data. Now, the 2 additional assumptions include independence of covariate and independent variable, and homogeneity of regression slopes. So, to begin, the independence of covariate and independent variable refers to the fact that there should not be a relationship between the 2. If there is a relationship between the 2, this is really, really bad. That means that they're related, obviously. So you wouldn't want to have a variable that you wouldn't want a covariate that has a relationship with the independent variable, because that means that there is an account from both ends, from both variables, and that's kind of like not what we want. That's completely the opposite. And we want to test for independence or for this specific assumption using a t-test or an ANOVA. The homogeneity of regression slopes, this refers to a relationship between your covariate and your outcome variable. And essentially it's the same across different groups. So those are their additional assumptions. Now, what am I going to be doing with an ANCOVA? So the assignment, well, the research topic I propose is examining the stress of gendered racial microaggressions, overall gendered racism experienced by Black women, and the possible impact that it has on their well-being. So the question I'm proposing is, can the stress of gendered racial microaggressions impact Black women's well-being while controlling for depression? My rationale for this test is very basic. I have a categorical predictive variable with three groups. My outcome variable, well-being, is continuous. The covariate that I picked, which is depression, is also continuous. So just at the bare minimum, because I have these three all together, I can run an ANCOVA. I think I covered everything. Yep. So to kind of introduce my data, ta-da! This here so you can see it all. Okay. So with this stress column, this is all the different groups for my data. So one is no stress at all, no stress. Second, two is moderately stressful. And then 3 is extremely stressful. Now I have depression scores, and these 6 scores were calculated to the average of these scores were taken to create the total well-being score, which is total WB. And there's a big disclaimer that I want to talk about in this video. The data that I have presented is randomized, or randomly generated, let's say that's a better word. And this has an extremely important impact on the data and our analysis more so. So what we find, if we find anything, that doesn't essentially mean anything. I want to get that clear, and that's pretty much it. So this is an introduction to the ANCOVA assignment and my data, and in the next video I'll be presenting R. Yep. Bye.